right. My name is Tony Yani Kalumbo, and I am a founder and director at DevBox. So DevBox is a network automation company founded in South Africa, based in South Africa, but we work with network operators basically anywhere around the world. And so this presentation speaks to the anatomy of a fully automated cloud exchange. Next slide, please. And basically, the idea is if you conceptualize your cloud, your exchange, you can actually virtualize it. And that really is a concept of actually having an internet exchange as a service if you can virtualize your cloud exchange. So, and that's the idea of making software the focal point of the internet exchange and developing virtual representation of every aspect of the organization as a software entity with API endpoints being important in enabling the automation and querying the different entities. So in doing that, one of the building blocks, or one of the first starting points is being able to understand all the business processes within your exchange and taking those processes and building workflows around it, and then that can be queryable and that can be automated. Next slide, please. So some technical considerations to take into account, just at a high level. One of the things that you want to do is, because you're provisioning the members, when you onboard members of the exchange, you have to provision the configuration on the ports that those members are connected to. So you would like to be able to have automated configuration management and also being able to model your network in an automated manner. You want to have a real-time virtual representation of your physical infrastructure. You want to have a real-time virtual representation of your interconnections and being able to query it and have real-time updates of the change of the state of your interconnect. And you want to be able to automate the configuration of virtual circuits. And I'm going to get into why I speak about virtual circuits. You want to be able to handle errors and also do version controlling on the different versions of the software that you roll out across your exchange. Obviously, audit, security, and compliance are important. You want to be able to give reports in real time, and you also want it to be API-centric. Since I put this presentation together, there's a few API standards that have come up for internet exchanges. One such standard is the IX-API standard, which a few of the operators, mainly in Europe, have been using, but it's an open source standard, so anyone can adopt it. And then obviously you also want to be able to integrate with other aspects of the organization, like the CRM, billing, and ERP. And why that's important is because you need to be able to identify each customer, and by identifying that customer, you need to be able to track the order that that customer makes, and you also want to be able to by tracking their order, you also want to be able to point out which devices and which ports those customers are provisioned on. So we will be talking about a cloud exchange, specifically the type of exchange that enables private peering, as opposed to an internet exchange that enables public peering. So this is more of a private peering exchange where you have fabric that allows you to onboard different members onto that cloud, and each member would have at least one cross-connects directly into the fabric of the exchange. And having that allows each member of the exchange to have an interconnection with other members of the exchange. And if you can go to the next slide, please. And that interconnection can be done in the form of a VLAN, which would allow you to automatically configure the interconnection between the two parties. And so doing so means that the member of the exchange only gets a single physical cross-connect, and they don't have to provision more cross-connects with all the members of the exchange, and the interconnection with the other members of the exchange become automated, and it's virtual because you're using VLANs to configure the interconnection between the different members. And obviously, you can also have redundancy. You can have two physical cross-connects that are in a redundant set, so you would push identical configs against the same cross-connect, or you could have them in the form of a lag or amlag, and that also gives an element of redundancy because then you can have a port channel across multiple appliances on the network. And so this really is the idea of a cloud exchange where you can have interconnection between all the different members of the exchange. Next, please. So this is, I'm not sure you guys can see this, but basically what we do then by having all the different entities and different aspects of the organization modeled, you can actually build a self-service portal where your members can log in, they can see the physical cross-connect, and then they can see who the members of the exchange are, and they can select which member of the exchange to interconnect with. So this screen really just shows that you can actually see the physical cross-connects that have been provisioned to each member of the exchange. Next slide, please. So a virtual circuit is pretty much the idea of having a VLAN between two parties on the exchange. And really, this really speaks to the model around it, where you have a network with another network, and one network would request to have a circuit with the other member of the network, and that would be managed automatically by sending emails between the two parties. And if the second party accepts, they will receive an email, they click on a link, they would accept, that would be seen as a formal contract between the two members of the exchange, and as soon as the other party accepts, the automation kicks in and automatically configures the configs on the A and on the B end and spins up a virtual circuit between the two members. Next slide, please. And basically, the slide speaks to the same. And pretty much this is kind of a workflow a typical workflow that would be followed in the approval process and the configuration or provisioning of the service between the two members. Next slide, please. Same concept, next slide, please. So again, I'm running through this, but one of the things as well is the members of the exchange could also be a cloud provider. And cloud providers such as AWS, Google, Microsoft Azure already have direct connects. In the case of AWS, Azure calls it, I think it's, I forget the name for it, but Google calls it a cloud interconnect. ExpressRoute is what Azure calls it. And basically, they have APIs into their direct connect, and those APIs are available on the public internet. So you can build a workflow into your organization around, first of all, onboarding an AWS direct connect into the exchange, and have a workflow to automatically provision a direct connect between one member of the exchange and the cloud provider in question. And that's all automated, and it happens within a few seconds. Next slide, please. And basically, again, when you log in, you would be able to see all the different all the cloud providers that are supported, as well as the circuits that are provisioned between the member in question and the cloud provider. Next slide. Cool. And basically, what we've done is we've built this platform in a way that is easy and intuitive, where the form that you'd fill in, I can't really see, but you'd fill in a few details that are necessary to actually go ahead and provision the circuit. And it would be the description of the circuit, it would be the unique account ID that you have with your cloud provider, and then you would also select which one of your ports you want to have the interconnection with the cloud provider, and the capacity as well, right? And possibly the region. And when you submit, those details are enough for the system to have the intelligence to actually know what to do and how to provision those the service. Next, please. And once you've provisioned the service, then you'll be able to see the details of the express route in the case of Azure, and you'd also be able to see like CRM information like service order. Next slide, please. And basically, to enable this, we kind of have a software model, as I said, that models every single entity of the organization. And this model is more of I'm presenting here an entity relational model that speaks to how you model a customer, how you model a service order, the products available on your exchange, as well as the service, if there's any CPEs, if there's any service delivery workflows involved. Next. And that goes into on the network side, there's the devices on the network, there's the configuration that is modeled, there's the location, the facility that your exchange is in, as well as the actual appliances. Next. So to enable something like this is basically what a typical platform would look like. There's user interfaces and API interfaces. There's application load balancing to enable a high availability, as well as to enable multiple concurrent users logging onto the platform and consuming a session on the platform. And at the center of this, there's a bit of an intelligence that we've built in, but that allows us to integrate with notifications, with ticketing. It integrates with the actual network. It integrates with the cloud providers. We provide telemetry, so we can extract telemetry from the network using standards such as GNMI, which is a gRPC framework for network monitoring. For telemetry data, databases such as InfluxDB and Prometheus, tools that we use to store the data and to extract time series telemetry. We use relational databases such as SQL. There's concurrency in the form of multiple processes kicking off continuously at the same time, so there's a support for concurrent processes running without interfering with one another. We obviously store documents and static files, so object store is something that's important. Integration into ERP, billing, CRM, and obviously authorization and authentication. Next, please. To enable this, we kind of built our lab using Container Lab, and we are. I'm personally heavy on containerization. I always try to find ways to virtualize pretty much any application that we work on. So Kubernetes is a great platform for containerization. So we model this in a virtual environment. We containerize, and we can actually virtualize the network fabric directly inside Container Lab. Next. And these are just like some of the configurations that that we set up in order to containerize the services. Next. And so one of the things that we've done that is really rare in the industry is to actually automate the configuration of a lag or MLAG. And so we've written some pretty awesome software that can allow you to provision lags across your network in a way that is reliable and to an extent pretty much foolproof. Next. As I said, IX API is a good standard to integrate with, and this allows using IX API as a way, as the API backend for, or at least as the API standard for your exchange, means that your exchange becomes compatible with a standard that anyone who's trying to integrate into your exchange in an automated fashion can adopt. Next. So we integrate with public clouds such as AWS. So this is like some AWS Direct Connect code that you can find on AWS's resources. Next. And this is for Azure. Next. And for telemetry, as I mentioned, we use gRPC and OpenConfig and extract telemetry directly from the network elements and store that telemetry into InfluxDB. If you can go next, please. And that allows us to have a GNMIC target that we can configure and points to the device in question. Next, please. And obviously, then all the telemetry gets stored inside InfluxDB, which is a time series database. Next, please. And the end result is that you can extract telemetry from your network and you can actually display it on a graph. Next. And I spoke about concurrency and message queuing. So there's awesome technologies such as Redis, RabbitMQ, Celery, and all these technologies are part of the tools that we've actually used to enable concurrency and to have multiple processes running concurrently. Next. Some of the underlying technologies that make up such platform, pretty much I have all the logos there, whether you're integrating into your network appliances such as Arista, Cisco, Juniper, or if you're a software developer who's trying to find tools to do this with, stuff like PHP, JavaScript, Python, or even Rust are tools that you can use for it. Operating systems, Ubuntu, Ubuntu, Red Hat, and specifically Ansible as well is a great tool for automation. Next. The development lifecycle obviously follows a CI/CD lifecycle, which speaks to continuous integration and continuous delivery, where your physical internet exchange can be represented in a virtual manner, and you manage it the way that you would infrastructure as code. And so the different versions of your code would be cycled, and you do continuous improvements on your code, and over time, those incremental improvements actually lead to a more reliable and a more resilient platform. Next. So some challenges and lessons. Projects like this, the biggest challenge is, first of all, getting buy-in from management. And once you have buy-in from management, getting buy-in from all the stakeholders who are involved in enabling automation. And this is not just for an exchange, just in any organization. Enabling automation requires that the entire organization is on board and the entire organization is actually patient to go from a place where there was no automation to a place where there's some automation, and then over time to have increased automation in the organization. And that, for me, I've seen is a process that can take 1, 2, 3 years to actually roll out pure automation and to actually have people talk about it as a concept, but then to see it become a reality that actually drives the organization. And so there are off-the-shelf solutions. In my experience, off-the-shelf solutions are not always practical because every network is unique and every network has its own nuance. So you may find an off-the-shelf solution, but then there's going to be that 20, 30% of the entire process that is just not covered by the off-the-shelf solution. And what ends up happening is that over time, people end up scraping the off-the-shelf solutions after investing in them. And I think network engineers think that network automation is just like writing some Python scripts and you've got automation, but it's actually a full organizational buy-in, and it's actually a real project that needs the whole organization to be on board. And it does not only just touch the network, but it also touches every aspect of the organization. As I touch your CRM systems, your billing, are all involved in getting automation to be a reality. Right. Next slide, please. I think that's it. And thank you for listening. And my email address is up there if you want to send me an email, chat to me, and if you have questions, website, and also host a podcast. So try to listen to some interesting things that me and some of my guests talk about. Thank you very much, guys.
Thank you so much, Tony. Please, let's clap for him one more time. Just a small secret. When he was speaking, I kind of remembered in those days when we used to configure different aggregation protocols on our Cisco switches, LSCP, MLAG, and all of that. And I just realized that the software guys have taken over my job. Anyway, thank you so much. Any question? Anyone? Okay.
Thank you for the presentation, Tony. Quick question. Can someone try this out while running a traditional network?
Yes. As I spoke, you can actually virtualize your entire network and actually model it and then roll it out once you are satisfied with the results. Yeah.
Or can you do it side by side?
I call it the concept of changing the wheels while the car's moving. So it is possible, but you've got to keep the car moving while you change the wheels, yeah.
All right. Thank you. Any other question? All right. Thank you so much, Tony. It was really fantastic having you. Please, we can do better. Let's clap for him one more time.